In this video we're going to look at how to plot straight line graphs using the gradient intercept method. And what this involves is your understanding of when you see a straight line graph represented as its formula, that you can find its gradient and its intercept, its y-intercept. If you can identify both of those things, then you should be able to use the gradient intercept method in order to plot a graph. Let's have a look at how we're going to achieve this one. This one says y equals 2x minus 1. Okay, so here is my grid. Remember, I'm trying to plot y equals 2x minus 1. Let's try and get them both on the same page. There we go. Okay, so what I need to do first is I need to look at my equation and identify that minus 1 is the y-intercept. So you can start your graph at minus 1 on the y-axis. Then what it says is that the gradient is 2. If we focus on this formula just for a minute, there are two numbers here. The one at the end here on its own is the y-intercept, that's minus 1, we've already used that, and the one next to x, the coefficient of x, is called the gradient, and that is what we're going to use next. So we've used the minus 1, there it is, I've plotted it already. Now the fact that the gradient is 2 means that every square along, every unit along, I go up by 2 units. 1 unit along, 2 units up. 1 unit along, 2 units up. Then what I'm going to do is just going to take my ruler and draw a straight line through those. And that's basically it. You found the intercept, you started there, and then you used the gradient to go up by 2 every time. Let's label that one y equals 2x minus 1. Okay, and now let's have a look at another example. This time it says y equals a half x plus 2. So this means that the intercept, the y-intercept, is at plus 2. So here we go. And this time the gradient is equal to a half. Now that means half a square every time. Or, if you think about going 2 squares along, 2 units along, that would be 1 unit up. So a gradient of a half follows this rule: 2 along, 1 up. And you can see, if I draw in those dotted lines, that the gradient of that is indeed going to be 1/2. So if we carry on that process all the way across the page and back a little bit here and join those points up with a straight line, we should find we've got the right one. So that one is y equals a half x plus 2. I started at the 2, the y-intercept, and I've gone up by a half every time. Okay, the third one I'm going to show you is y equals 5 minus x. Okay, so in this one the difference here is that the gradient this time is not immediately obvious. It's actually this number here, which is a minus 1x. The number of x's is 1 and it's a negative 1x. So the gradient is going to be minus 1. The intercept is the number on its own, which is a 5. So we start with the intercept of 5, and then I'm going to use my gradient of minus 1 every time. So here we go. 5 minus 1 minus 1 minus 1 minus 1. I'm going down by 1 unit for every unit across. And again, draw a straight line through that all the way across the page, or all the way across the grid I should say, and that is the equation y equals 5 minus x. Now that should be fairly straightforward if you understand your gradients and your intercepts. If we just recap all of them, 2x minus 1 passed through minus 1 and had a gradient of 2. Half x plus 2 passed through plus 2 and went up by half a square or half a unit for every unit along. And y equals 5 minus x started at 5 and went down by 1 unit because it was minus 1x. Now the last graph that I'm going to show you involves a more sort of applied straight line graph. Okay, the graph we're going to draw is this one. I want you to imagine that this has been put in context. So we've got a company which is charging for its services, and the rate is £50 plus £20 every day. So we have £50, and then on day 1 for a whole day you'd be charged £70. For 2 days you'd be charged another £20 on top of that, etc. So let's have a look at how we plot this. Well, first things first, we don't have x and y anymore. We have c and d. That's no problem though. We've just exchanged the y and the x. If you look here, I'm going to actually just put in brackets underneath there a y and an x just to remind me. So this number is the gradient and this number is the intercept. Okay, so we're going to start when drawing our graph at the point 50, which is just there. And then remember that the gradient said 20. Just to remind you, the formula we're using was c equals 50 plus 20d. So the gradient is 20. That means that for every unit along, we go up by 20 units. Now, one common error number 1 is to use squares, not units. Okay, so if you were going to count the squares here, you would go 1 square along, 20 squares up, immediately you'd be up here, and then 1 square along and another 20 squares up. That would be a mistake. The reason that's a mistake is that the rule is the gradient is how far up you go for every unit across. Not dealing with squares at all, we're dealing with the units on the graph. So we go along 1 unit and up 20 units to there. And then along 1 more unit and up 20 units. If you're struggling to see the grid lines at this point, what you do is take your ruler and you just use your ruler to mark out where you're going to go. Okay, maybe even with a see-through ruler. So error number 1 would be to use squares, not units. I've avoided that. I've used units. So I've gone along 1 unit and up 20 units. Along 1 unit and up 20 units. So I'm getting my graph correct now. The other mistake that people make, and this can be quite common, is not using enough points. To plot their straight line graph. Okay, if we have a look at this one now, I could put my ruler on here because I've just got 3 little points down here, right? I could sort of put my ruler like this, or I could put it like that, or I could put it like that, and it's all sort of going through all 3 crosses. There's just a lot of room for error if you've got 3 points which are all really close to each other. So what you need to do is either keep going with this method of along 1 unit, up 2 units, like that, or you could just put, for example, on this one, the number 7 into this formula. If you put 7 into this formula, you get 50 plus 20 lots of 7. 50 plus 20 lots of 7 is 50 plus 140, which is 190. So I can immediately plot 7, 190, just there, paying real attention to the scale that I'm using. And suddenly, because I've got points which are further away, it becomes really accurate when I plot my straight line. So do watch out for that. Okay, number 1, you've got to use the units which are available. So an error would be to use the squares, not the units. And error number 2 would be not using enough points. I hope that's helped you to plot graphs using the gradient intercept method. Do take care with your units and your scales on graphs. It's probably the most common reason why clever people lose marks.